Today, I will be discussing about the logistic regression equation. Before going into deep of that type of equation, we start from the beginning. You know the regression equation. Suppose conjunction, C for conjunction, alpha plus beta income plus U. Okay. So consumption depends upon the income. So here consumption is quantitative variable and income is also quantitative variable. So if we draw this equation in a two-dimensional space, then this is the dependent variable. So we are measuring consumption here, and this is the income. So we are measuring the income here. Okay. So now this is alpha. It is constant and it represents the intercept. Here on the vertical axis, the intercept, it is assumed, and the line, this is the regression line, alpha plus beta y plus u. So this is the line, regression line, because consumption and income, two variables, and there are so many points, and this line represent such a line which is good, which is good fit among these points. Okay, so alpha is the intercept and beta is the slope. Beta is the slope. It means one unit increase in y, how much effect is there on C? It is beta. Okay, it is beta. So this is the slope. Now, this is the simple regression, you know all about this. Now, suppose you were taking the dummy variables or qualitative variables in place of independent variable, that is the quantitative variable, and we replace this quantitative variable with the qualitative variable. So, for example, suppose weighs alpha plus beta and you can say the experience plus UI. Okay, so weighs depends upon the experience. So experience is a qualitative variable. Why it is a qualitative variable? Because if the laborers are male or female, on that basis experience may differ. So male and female, so here are two categories, that is male and female. Okay, so if this represents the male, then weights will differ, and if it is female, then weights also differ. If a researcher tries to find out such a difference, whether there is a difference in weights as they are male or female, then he should use the dummy variable. Dummy variable, suppose Wi equal to alpha plus beta experience EI plus gamma for male plus ui. This is the dummy variable. Okay, and it is male for 1 and female for 0. Okay, so I am, so if this represents the 1, then you have alpha plus beta ei plus gamma plus ui. Okay, so this alpha and gamma is alpha plus gamma plus beta ei. Beta ei, if we take the expectation of these, wi, expected ui, and it is not here, so ei, then look here, the intercept has been changed. Intercept has been changed. So this is the beta hat. This is the beta hat, and this is the alpha hat, gamma hat. This is alpha hat. This is gamma hat. So alpha hat plus beta hat. This is the intercept. So here it is visually clear that alpha hat is not equal to with the alpha hat plus gamma hat. Okay, why? Because the persons who are getting wages, the wage differs as because the person is male candidate. So if it is female, then it will be 0. Okay, it will be 0. So it will be 0 here, and this part will not be there, and also this is the, and this part also will not be there. Okay, so alpha hat. So this is the intercept. So this represents the intercept. This intercept represents the ways if the candidate, the FOS ways, if the candidate is female. So in this way, we can use the dummy variable. Okay. Now there is, the dummy variable trapped, and I am not going to deep in this, but if there is suppose male and female, there are 2 categories, and you are using 2 dummy variables for the 2 categories, then there will be dummy variable trap. And in my another lecture I will explain about this. And so if there are 2 dummy variable, if there are 2 categories of a variable, then you should take one dummy. So now if all the variables, independent variables, explanatory variables are explanatory variables, are qualitative, then the system is called the ANOVA. Okay, analysis of variance, ANOVA. Now if there are some independent, there are some qualitative variables, some quantitative variable in the dependent variables, then it will be called ANOVA. And now if this dependent variable is a qualitative variable, that is 1 and 0. so the value is 1 and 0, then it is called the, so if this dependent variable is a qualitative variable, then and all the variables here in the explanatory, all the explanatory variables or independent variables are quantitative variable, or then that equation is called the you can say the base of the logistic model. So I am going to this regression equation in this way. Okay. So now look, suppose the sale, or you can say sold here, and alpha plus beta price plus ui. Okay, so this is a regression equation here, and this is the price of car, and this is the sold. That is, if the price is at a certain level, certain low level, then the car is sold, and if it is at a certain high level, the car is not sold. So in between that two certain values, there is no selling of the car. So this high and low value, certain value, that are represented by the 0 and 1. If it is 0, the car is not sold, and if it is 1, the car is sold. Then you know it has two values. Okay, 1 and 0. At 0, the car is not sold, the price is very high, and it is 1, it is sold. So diagrammatically you can have this idea. Suppose this is 1 and this is 0, and we are measuring the probability, and here is the price. So if the price is very high, and here is some point, and here is some point. Okay. So if you draw a regression line, then you have like this. So this regression line has some problem, you know, because if the price is very high, suppose beyond this point, toward this direction, then the probability will be negative, you know. But it is very difficult to explain. Theoretically, it is not correct. So this is the problem. Now, suppose I am writing this in this way: probability alpha plus beta pi plus ui, and I divide this probability by 1 minus p. Then this thing is called the odd ratio. The odd ratio, okay? This thing is called the odd ratio. So this is the odd ratio, and now look, from this equation we are here, pi equal to alpha plus beta, this is price, this is the probability, this is the price, and now plus ui. From these we are here, here. Okay, so now the value of these is, you know, I have mentioned 0 and 1, and midpoint is 0.5, 0.5. Okay, for this regression equation. Now, this is the odd ratio, as I have mentioned. So it has two values, that is, one is 0 and infinity, and 0 and infinity, and midpoint is 1. How? It is because suppose it is near about 0.01% of probability. So if it is 0.01, it is nearly 0, and it is very small, so 0 divided by 1, it is 0. So the extreme point is 0. Okay? And now if it is 0.98, then 0.98 divided by 1 minus 0.98, then this part is nearly 0. So the value of this odd ratio is infinity. Clear? So this 0, within 0 and infinity, the midpoint is 1, because if it is 50% probability is there, 50% probability of salt, and then 1 minus 50%, the 50% it is 1. So midpoint is 1. 50%, 1 minus 50%, it is 1. Okay. So it is
Start.
So this is the range. Now, what is the problem of this regression equation? Look, this is 0 and infinity. So 0 and infinity, the distribution would be like this. It has long tail to the infinity, and midpoint is 1. So the problem of skewness is here in this regression equation. Okay, so we have to remove this problem of skewness from this regression equation, and now for that reason we are taking the log of P1 minus P, that is the probability, equal to alpha plus beta Pi plus Ui. Okay, so look, now the range is minus infinity to plus infinity, and midpoint is 0. And in the same way, if you take the 50% probability of salt, so 50%, 1 minus 50%, that is 50%, 1, log 1 is equal to 0, so midpoint is 0. Now it is maximum, suppose 98%, so 98% divided by 1 minus 98%, so 1 minus 98%, so log is near about 0. So here it is the minus infinity to plus infinity is the range, So the distribution is look like this. And this is the midpoint 0. Okay, now look at the same way, in the same way we can put the values of P, extremes and highest extreme, highest point and low point, that is 0.2% probability of salt, and 0.98%, 98% probability of salt. So putting this value, you can have this range. So by taking the log of this odd ratio, now we have removed the problem of skewness. Okay, so look here. So I am writing again. Look, log Pi minus 1 minus Pi equal to alpha plus beta price pi plus ui. Okay, so now if the price is very high, for example, I am taking I am assumed the value in such a way alpha minus 0.228 0.28 pi plus 0.28 pi, and this is the log pi by 1 minus. So what does it mean? It means that 1 unit change in price will negatively affect the log odd ratio. That is, the log odd ratio will fall 28%. So this does not represent actually nothing. And what you understand, the log odd ratio is falling or decline, and so it should be clear. It should be clear. And how it should be clear? Look, suppose after calculation you have it has a value also, and it is here it is a value. So if you put the values in Excel, then you can have the log of this. That is, for example, log pi 1 minus pi equal to, suppose this is 0.30, for example, 0.30. So now we take the anti-log of this. Okay, so if we take the anti-log and then pi 1 minus pi, it is assumed, okay, suppose 0.19, or for calculation, simple calculation, 0.15, for example, anti-log, after taking the anti-log. Now, so P equal to, next line, P equal to 1 minus P, 0.15, now equal to 0.15 minus 0.15 P, okay, this is P, or now P minus plus 0.15 P equal to 0.15, okay. So P 1 plus 1 5 equal to 0.15. So 1.15. So here I am writing here P equal to 0.15 by 1.15, and this number, it is assumed, okay, for calculation it is assumed, so it is not real calculated number. So 0.15, 1.15, and this is 0, so I can cancel it. So 15 divided by 115. So if we divide this, so what would be the value? Using the calculator you can have, or you can say in this way, 15.0. So 1,115.5 3 5 4 3 5. Okay, so in this is a 0.13%. So P, the value of the P is 0.13. So what does it mean? It means if there is an increase in 1 unit in P, the price of the car, then the probability of sold is 13%. Probability of sold is 13%. So this is a way through which you can analyze the logistic regression model. Okay, so in this video I have tried my level best to analyze the logistic regression model, or logistic model, so that you can have a minimum understanding for further research. Thank you for enjoying this lecture.